to that you say, hey, if it'll run on this, it'll run on any other device?
I don't have enough to really establish that. I have one that doesn't have high precision fragment shaders, so
So
I assume
within your own personal collection of devices, you have one that you go to.
yeah,
Okay.
yeah. And you mentioned snippets. I've got these functions loader.fragment shader and loader vertex shader that will look through the code. The code is just a string, right? So you can use the Lua string utilities to search through it. And that also lets you do things like build your code, generate your code dynamically if you need to hard code some constants in, that sort of thing. But I go in and look for some of these functions, like simplex and stuff, that I've defined in a library. And what it will do is string them together so that I can build things out of snippets. Okay, so we got that, and it'll build this fragment. So.
Oh, okay. So it's outputting it as a so you can see everything that's all been combined.
Right. So I've got a sphere utility, and I've got a noise utility, and it gets to be a huge file if you've got them all in one big lump. So I string them together, but I don't know how well written the GLSL analyzer is. I'm sure there's ways to break it, but it's been helpful.
That's pretty cool. That's a kind of a nice little nugget there.
Yeah.
I like tools that generate tools. That's how the robots, that's how the robot uprising starts.
Right. So I'm going to cover a couple of these. I have two shaders. This one has 4 parameters. You can specify the top, the right, the left, and the bottom. And it lets you peel away an image from the center until it's complete, or until it's a point, whichever way you go. So I have this, and I have this that lets you expose a bunch of points, right? And let's see, this one just uses a bunch of sine waves and checks whether the current texture coordinate is within the bounds defined at whatever height and width it's at. If it's not, just emits a clear pixel. Otherwise, emit the texture. And these these aren't using a noise function, but they use enough sine waves to look like noise. And this one takes some input, so some integer, or it doesn't have to be an integer, just some number, and it randomly chooses a bunch of points using a fairly cheap rand. This is kind of like what the built-in Lua rand uses. It's just a multiply then a mod, and it doesn't have great properties, but it spaces these points out enough. And if they're within a distance, it draws the pixel. If they're within a distance of any of those points, it draws the pixel. Otherwise, it's just another clear pixel, as I said. So the reason I bring those up is because these assume that we have a coordinate system that goes from 0 to 1 and 0 to 1, right? Which will be true if all we're doing is using an image, but we might be using an image sheet. And then we're at some arbitrary frame. And suddenly we don't have from 0 to 1 anymore. We have, from 0.2 to 0.3 and whatever. So using some tricks like centering it at 0.5 aren't going to work. They're just going to give garbage. So we need some way to tell the shader I'm centered here. And in the vertex shader, we get the positions of the corners, or we get the positions of the texture coordinates around. And there's not a lot of support for the texture coordinates, but because there's nothing in Corona that will give you the 0 to 1 coordinates for a frame of an image sheet. You have to synthesize it yourself from the image sheet data, and not very convenient. But if you have a position for the center of the frame where you put your display object, then in the vertex shader you can say, oh, this is the corner I have. Where is the center relative to the corner, to the vertex in the corner? If the x is greater, we can say, oh, the texture coordinate is 1. If it's less, we can say it's 0. And ditto for vertically. Does this?
So you're sort of dynamically calculating the edges of your image based on the center point, and
yeah, we're making an equivalent from scratch.
Gotcha.
So, and I'll quickly show. I did briefly cover that, or I at least looked at it in the last show, but I didn't get a chance to explain what was going on.
Mm.
So here in oh wait. Okay, so in the Vertex Shader, this step function, what it does is it takes a value, and if the other value you give it is less than the first value, it returns 0. If it's greater than or equal to the value, it returns 1, which is exactly what we need, because we want a 0 to 1 coordinate system. And I think I briefly covered this last week too, that if you pass in a 2-element input, you can also pass those into these functions, and they'll give you 2 elements back. So they'll call it for each element. So we get our 0, 1 coordinates in the vertex shader, and then we feed them into what's called a varying, as opposed to a uniform. And a varying will get interpolated between our vertices and passed into the fragment shader in that interpolated form. So does that make sense?
So basically in our shader, we're sort of dynamically getting the size of the shader itself. Am I misunderstanding?
Well, so I evaluated the center at some point.
Yeah.
Right? And I passed the center in through the x and y. And using that, then I can get texture coordinate system around me, or you shouldn't really think of it as textures anymore, I guess, but just values between 0 and 1.
Okay.
0 on the left or the bottom, 1 at the top right.
And that becomes most advantageous to us when we're doing what?
These would be for if we have image sheets or anything with a frame where we don't have just one image, where we have images that could be anywhere in the texture.
Gotcha. Okay, gotcha. So non-uniform size images that are in an image sheet, and then we're using shaders to manipulate them in some way. And so now we need to kind of flip through and figure out, well, what's the size of this this image so that we can apply the shader correctly to it.
Yeah, and I don't know how much time we want to go to, but I'll show something really quick that uses these two that I just showed you.
Okay.
So this is